Hello NI students, welcome to the CAD/CAM laboratory. In this lab session, we are going to learn about how to create the parts of Plummer Block assembly in SolidWorks 2015 modeling package, and then we are going to learn about how to assemble the modeled parts and how we can generate the orthographic views, that is front view, top view, side view, and isometric views of the Plummer Block assembly. So this is the off-sectional front view of the Plummer Block assembly. As you can see here, there are 8 parts. There are 8 parts in this Plummer Block assembly. Let's go for listing the parts of the Plummer Block assembly by looking at the part drawing sheet. So this is the part drawing sheet which will be given to you in the examination. Based on this part drawing sheet of the Plummer Block assembly, you are supposed to go for creating or modeling each part of the Plummer Block assembly, and then individual parts should be assembled together. So first let's look at the bill of materials table of this Plummer Block assembly. So as we can see here, there are 8 parts listed, and body 1 is the first part. Second part of this Plummer Block assembly is cap. Third part is bearing bottom off. Fourth one is bearing top off. Fifth one is bolt, that is M10 bolt. Sixth one is M10 nut. Okay, so this nut will be called as the load nut, and seventh part is the M10 nut again, but this will be called as the lock nut. And the last part in this Plummer Block assembly is the shaft. As we all know, the Plummer Block is used to support the long bearings. Okay, so therefore let's go for taking up the first part, that is body of the Plummer Block. So in this part drawing sheet, for the body, they have given the off sectional front view here, and the top view, corresponding top view, is given here. So therefore, for the part number 1, that is body, they have given the front view and the top view. Okay, so with the help of this front view and the top view, we should get the 3-dimensional representation of this body. Okay, so in order to do that, I will go to the SolidWorks 2015 modeling package here. Then I will click on the new icon here, and I will go for selecting the part layout, and then click on OK. So as they have given the front view here, so first what I do is in the front plane of the SolidWorks, I am going to create this outer profile of the body. So this outer profile of the body, okay, so that is this one. So this outer profile of the body, okay, will be constructed in the front plane first. Okay, so this profile, okay, you should observe at the cursor. Okay, so the way in which the cursor is moving now, so that profile will be created first in the front plane. Okay, so therefore I will select front plane under the feature manager here, and then I will go for features sketch tab. Then I will select sketch command. So once sketch command is selected, I'm going to select line command. Then I'm going to choose this as my starting point. From here I'm going to draw one vertical line. So first one vertical line will be drawn, okay, which is the axis here. Okay, vertical axis passing through the body of the Plummer Block. So this vertical line will be drawn first, then this arc will be drawn, and then there is a small vertical line here for 3 mm length. Then we will draw this horizontal line. So therefore let me choose this as my starting point, okay, or let me choose this point as origin in my SolidWorks. Okay, so I'm going to start the sketch from the origin. So first I will draw one vertical line. So this vertical line corresponds to this axis of the body, vertical axis of the body. Then I need to draw this arc now. Okay, so this actually arc is having radius of half of this 38, okay, which is shown given here. So, okay, so therefore what we do now is when I want to construct the arc, I will take the cursor back to the last point of the sketch here, and then when I try to move the cursor okay, away from the point, so I will get the arc. Okay, so this is a simple way of getting the arc. Okay, so I'm going to place the arc something like this. Then I will draw one small vertical line now. So you should see here, so from here to here we have the arc, and then from this point there is a small vertical line here. Don't forget to consider this a small vertical line here. This small vertical line is having a height of 3 mm. Okay, so therefore I will draw one small vertical line, and then small horizontal line will be constructed here. So small horizontal line, and then we need to draw again vertical line here. So we need to draw this vertical line. uh, After that we need to draw this horizontal line from here to here. Draw the horizontal line, then again draw the vertical line here, okay, from here to here. So approximate vertical line will be drawn. Okay, so then we need to draw the horizontal line up to here. Draw one horizontal line, then we need to construct one inclined line here, which is for a height of 14 mm. So I am not adding any dimensions right now. Dimensions will be added later. Okay, so then from this point to starting point of our sketch. Okay, so from this point to the starting point of the sketch, one more horizontal line has to be constructed. So construct that. Okay, once this much is done, if you look at this front view or the top view, okay, so they have not given the dimensions from the vertical axis. So all the dimensions are given like from here to here, okay, from here to here, okay, and the distance from this center to this center, okay, the distance from this center of the world to this center of the world. So therefore all the dimensions are given between the extreme limits, not from the vertical axis. So dimensions are not represented from the vertical axis. So therefore, in order to add the dimensions easily for the created sketch, what I do is I will go for taking the mirror. So this is the right profile of the body in the front view. Okay, so in just instead of dealing with only the right profile of the body, what I do is I am going to take the mirror, and I will also construct the left profile of the body. So how it can be done? So go and choose the mirror entities here. Okay, so click on the mirror entities in sketch command. Okay, under sketch command. Okay, so then what we do is I'm going to select all these entities in the sketch. Okay, so you can see all the lines in this particular sketch have been selected here. Okay, so then we have to mirror this sketch now. Okay, means we have to mirror all these lines and arcs present in this sketch. They should be uh, they should be uh, they should be mirrored. But the question is about which line they should be mirrored. We have to mirror this about this vertical line now. So therefore select this vertical line here. So then click on OK. So now you can see we have got the full profile of the body in the front view. Okay, is that clear? So once we get this full profile of the body in the front view, so then what I do is I'm going to click on the center line here. Okay, I will click on the center line, and I will use this center line only for construction purpose. Okay, make the center vertical line as the solid line as the axis line. Once it is done, now we can go for adding the dimensions. So now let's see how the dimensions can be given. First I am going to fix the overall height of this body. Okay, so the overall height of the body can be read in this front view here. It is 55 mm. So therefore I'm going to select smart dimension now, and from this base line to this top line I'm going to give the distance as how much now? The distance is 55. So we can add this as 55 mm now. Once we define the overall height, then what I do is I'm going to define also the overall length now. So the overall length length, okay, of the base of the body is how much here? It is given as 168 mm. So therefore I will select this bottom line, and I will give this length as 168 mm. So this should be given as 168 mm. Once this is done, okay, so then I will start from the inner dimensions now. So first I'm going to define this diameter of or the distance of 38 mm, which corresponds between ear to ear. Okay, or what I do now is I'm going to take the distance from this particular line to this particular line as how much now? It is 38. So that will be given here. So 38. Okay, so then what I do is I'm going to give the distance between this line to this line as 44. So therefore I will select this line and this line, and this will be given as 44. Okay, so then I'm going to give the next higher horizontal distance. So that is 168 has been already given. So next we need to give the distance uh, from this center to, okay, so central axis to this particular edge here. Okay, so this vertical edge. But in the front view we cannot, they have not given the distance from this line to the central line, or this line to this line. So what we need to do is we need to look at the corresponding top view now. So in the corresponding top view, this particular arc, okay, so the arc which is given in this top view here, this corresponds to this extreme vertical edge here. Okay, so this one. So therefore they have given that this particular arc, okay, this particular arc is having radius of 43, means the distance from this center to this point on the arc is how much here? 43. Means this center corresponds to this axis here in the front view, and this particular arc corresponds to this line here. Okay, so therefore the distance from this line to the central axis should be 43 now. So therefore what I do now is I'm going to select the central axis and this line, and I'm going to give this value as this value should be how much now? 43. So this will be given as 43. Okay, once this is done, I'm going to give this base height here. Okay, so the base of the plumber block body is having height of 14 mm. So I'm going to give this as 14 mm. So then for this inclined line here, okay, the horizontal distance is given, that is 4 mm. That is okay. So this inclined line is having horizontal distance of 4 mm. Enter that. Okay, so now almost all the entities of this sketch are constrained now, because all those entities have turned to black color. Okay, but this central arc here and this horizontal line are appearing in blue color. So what we do is we go for defining the radius of this arc now. So the radius of the arc corresponds to 19 mm. So that is what they have given here. So, okay, so it is 19 mm. So let's see. Okay, so what value we need to change here? I think we have not added this small, we have not added the length of this small vertical line present here. So after this arc, okay, so there is a small vertical line of 3 mm length. This length has to be added now. So therefore smart dimension, I am going to select this small vertical line here. This should be 3 mm. So this has been done now. So now let's see why it is not constrained. So still there is a freedom. So now when we try to move these blue color entities, so this arc is having freedom to move in the downward direction or upward direction. So therefore we need to constrain this. So now the question is how to constrain this. So let's look at which dimension should be added. So here we need to add the dimension of, okay, uh, dimension of this 12 mm, that is the distance from this top edge to this small horizontal line here, okay, should be 12 mm. So if this if we add this dimension, okay, the sketch is going to be constrained. So this distance should be how much now? So this should be 12 mm. So therefore I am going to give this as 12 mm. Okay, okay. So now once we add that 12 mm distance, now you can see I think let me turn on the status bar. I think status bar is not appearing here, because once all the entities turns to the black color, that is the indication of the sketch is completely constrained. Okay, so let me turn on the status bar here. So once the status bar is turned on, okay, you can see now here the sketch is showing it as fully defined. So once the sketch is fully defined, I can come out of the sketch now. Okay, and I'm going to keep this sketch in the isometric view. Okay, and I'm going to check whether the sketch is created in the front plane. So the created sketch is overlapping with the front plane. So therefore we have created the sketch on the proper plane or on the right plane. Okay, then I will select the sketch one again. So now I need to add the material within this profile, created profile. Okay, and the material should be added perpendicular to the profile. Okay, so I will go to, whenever we want to convert the 2D sketch to 3D, we go for using this features manager tab. Under features manager tab, go for choosing extruded boss feature. Okay, so try to select this command now, features. Okay, in the features tab, try to select the extruded boss command. So once it is selected, okay, so by default the software is trying to add the material in front of the sketch. But what we do is, since there is a symmetry now here, okay, so when we try to look at this top view, okay, so this is the horizontal axis passing through the middle of the body when we see from the top view, and the material is distributed equally on either side of this horizontal axis in the top view. So therefore there is a symmetry in the top view. Therefore what we do is instead of adding the material on one side of the sketch, we go for adding the material on both the sides of the created sketch by using this mid plane option. So use the mid plane option and go for giving the depth of extrusion as 36 mm now. So here the depth of extrusion should be 36. Give OK. So this is the initial model. So this is the initial model we are getting for the which one plumber block body. Okay, but still we need to add a lot of features for this body. That is, if you look at this body front view here, so there should be a hole here. Okay, for inserting the bolt, and there should be a elliptical hole here. Okay, and there should be a small hole of diameter 6 mm at the center here. Okay, and we need to also make one rectangular cutout at the base of the body, so that is here. So still we need to add a few more features for this body. And also right now, as you can see here, this particular face is flat, but means when I try to keep this model in the top view, we can see now if I try to keep it in a wireframe mode, this particular edge is looking like a straight edge, okay, or the flat face. But if you look at here, this particular face here, it is not it is not flat face. This corresponds to the curved surface here in the top view. So therefore this particular face, okay, should be curved. Okay, is it not, with a radius of 43? Okay, so therefore we need to add few more features to get the final body of the plumber block. Now let's see how it can be done. Okay, so first what I do is I'm going to convert this flat face here into the curved one. How it can be done? So in order to do that, I'm going to select this top face here, and I'm going to create sketch on the top face. Okay, select the sketch command and keep it in top view. And then what I do is I'm going to draw one circle now. Okay, from the choosing origin of the SolidWorks as the center of the circle. Go for constructing a circle, okay, like this, and this circle should have diameter of so here the radius is given as 43, so therefore we need to enter the diameter here as 2 into 43. Okay, once it is done, okay, you can see the sketch is fully defined. So let me turn this model to isometric view. So this, okay, so you can see here we have created this circle, okay, on the top face of the body. Okay, once it is done, what I want to do is I want to cut the material outside this circle and in the downward direction. I want to cut the material in the radially outward direction from the circle and in the downward direction. So how it can be done? So I will come out of the sketch mode now. I am going to features command tab. Okay, there I am going to use extruded cut option now. Use the extruded cut option. Okay, so by using this extruded cut option now, right now, okay, the preview is showing like we are trying to cut the material inside the circle, but I don't want to cut the material inside the circle. Okay, we have to cut the material outside the circle. So in order to change the direction of cut, okay, so we have to use this flip side to cut option here. Okay, so click on this. So now you can see there is an arrow appearing here. This indicates that material will be removed outside the circle, okay, not inside the circle. So then we need to cut the material, okay, from where to where? We need to cut the material from this face to this particular face. So what I do is I will go for using up to the surface. Up to which surface the material should be cut now? So we have to cut the material outside the circle and in the downward direction here and up to this particular face. Okay, I have selected this face one. So means from the sketch up to this particular selected face, which is showing in pink color now. Okay, the material should be removed. So then click on OK. Okay, so once it is done, you can see, okay, the body is going to appear like this. Okay, and if you try to keep it in top view now, you can see earlier there was a straight edge. Now we have got the curved edge here. Okay, circular edge is appearing in the top view. Okay, so let me again keep the model in isometric view. Okay, so then what I do is I go for, once we make this flat face as curved face. So next we should go for we will go for adding this small cylinder here. So this small cylinder cylindrical hole, okay, this small cylindrical hole has to be done on this curved surface here. Okay, on this curved surface, a hole of 6 mm diameter with V bottom has to be made. Then how to do this? Okay, so that I will explain now. So in order to do that, in order to make that hole now, okay, so we can go for using a hole wizard option. Okay, we can use this hole wizard option. Okay, so but what we do now is, you need to remember, when we want to make the hole wizard option, hole has to be placed perpendicular to the flat surface. Means we need to have one flat surface. So and we need to locate the center of the, we need to locate the position of the hole to be placed. So in order to do that, first what I do is, I'm going to select this top face again, sketch, okay, and then I will keep it in top view. Then I'm going to construct one small circle now, somewhere here. So circle will be constructed by taking origin as the center. Then I'm going to simply give this diameter as, so I'm going to give this diameter as 6. Actually not required. So just this is just for our reference now. So do this. Now when you try to tilt the model, you can see this is where we have created this circle. So why I have created this circle is, I am going to use this circle as my reference for placing the hole. Now what I do is, already this portion is hollow. Okay, so there is no need to make hole in this hollow portion. So we need to make a hole for a diameter 6 mm and for a depth of 6 mm here, and that particular hole should have V bottom. That's why what I do is, I am going to select, okay, and you need to remember, we cannot place the hole on the curved surfaces. We need to start the hole from the flat surface. Okay, so I will go for the features command tab now, and I will go on click. I will go and click on the hole wizard here. And then what I do is, when we select the hole wizard option, you can see here, okay, so there are two options. First we have to select the type of hole, and then we have to select the position, where the hole has to be placed. Okay, so I will select the, I will go for selecting the type of hole first. So as you can see here, this is counter bore. Okay, so this is counter sink hole, this is simple hole. So what I do now is, I will go for selecting this simple hole. Okay, and this simple hole should have diameter of 6 mm here, so that can be selected somewhere here. So that is, it is not tap drill, so I'm going to, so we cannot have tap here, so I don't want tap. So let me take this as, I don't require tap. Okay, so change the type of hole to simple holes here. Okay, without the tapping. And then I'm going to select the diameter as 6 here. Okay, and then what I do is, it is asking for V bottom. V bottom is 118 degree. Okay, and what should be the depth here? So the depth, so while giving the depth, we need to be careful. Okay, because from this curved surface, the whole depth is 6 mm. But as I told already, we cannot place the hole on the curved surface. Okay, that's why what I have done is, I have created a circle here. Means from this, by choosing the center of the circle as the position for the hole, I am going to cut the hole in the downward direction. So therefore, from this top face here, what is the total depth we need to give, that I am going to calculate now. Okay, so from this top face, okay, so from this curved face, from the base of this curved face here, the depth of the hole is 6. From here, if the base of the, from here, if the depth of the hole is 6, then we know that the distance from here to here is 38. Therefore, the distance from this base of the curve, okay, curved surface to here should be how much? 38 by 2, that is 90. Then already here, from here to here it is 3, here to here it is 12. So therefore 19 plus 3, it will become 22, 22 plus 12, okay, 22 plus 12, 34, okay, and for that 34 I am going to, means instead of saying that from this base of the curved surface, the depth of the hole is 6 mm, we can also say that from this top face now, from this top face of the body, okay, what is the depth of the hole? So this base of the curved surface itself is at a distance of 19 plus 3 plus 12, that is 34 mm from the top face. And from that 34 mm from the top face, again we need to move down by how much? 6 mm more. We have to move downwards further 6 mm. Okay, so therefore total distance, okay, will become how much now? That is 34 plus 6, it will become 40. So therefore Okay, let me recalculate again. So 19. So from here to here it is 6. 6 plus 19. It is uh, it will be 25. Okay, 25 plus 3. It will become 28. Okay, 28 plus 12. It will become 40. So therefore, what I am going to do now is, so I am going to define here the total wall depth as 48. So total wall depth is how much? 48. And we don't require any countersink hole here. So therefore, I'm going to, so now I have completed the which one defining of hole specifications. So I have selected a simple hole with a diameter of 6 mm. Okay, so diameter is 6 mm here, and it is having V bottom with 118 degree, and this one, the end condition, the total wall depth now I am choosing as 40. Why I am choosing as 40? Because I am going to define the wall from this particular top face, not from this curved face. Okay, so therefore the total wall depth should be 40. Then I will click on this position. Okay, and then I will come and click on this top face here. Then you can see now there is a preview coming. Okay, so you can see a preview here. So now I am going to change the view to top view, and I will take the cursor and I will click on this uh, origin or the center of the circle that we have already created. Click there. Once it is done, you can again change the view to isometric. So still we have the option to place a few more volts. Okay, for the selected which one uh, wall specifications. Okay, but as per the part drawing sheet, we need to place only one wall now, and you can also keep it in front view and you can verify. So the wall is coming from here to here. Okay, so then click on OK now. So you can see there now wall has been formed. Now how to verify that whether there is a V bottom placed or not? So for that I am going to click on this section here. So once section is taken, when you try to keep it in front view, you can see that we have placed a wall now, okay, which is having V bottom, and it is having diameter of how much? 6 mm, and it is having depth of 6 mm from this base of the curved surface. But okay, this wall is having okay, depth of 40 mm from this top face of the body. Okay, this is what you need to remember when you go for making this which one wall. Okay, so this a simple wall with V bottom. Once we place this wall, then what we need to do is we should go for and also I go for hiding this sketch which I had created for my reference purpose. So I will go for sketch 3 and I'm going to click on this hide option. Okay, so then what I do is next I go for making this first I go for making this rectangular slots here. So you can see here this particular hidden line here corresponds to, okay, this rectangle in the top view. Okay, means, okay, we need to make a rectangular cutout from the base of the body for a height of 2 mm here. Okay, means what I am trying to tell here is this particular portion in the front view. Okay, this particular portion in the front view corresponds to this dashed rectangle in the top view. Okay, is that clear? Means from the base of the body we need to make a rectangular cutout for a height of 2 mm. Okay, and this rectangular portion, okay, should have, okay, so let's check it here. Uh, Somewhere here it should be given. Let me check. What is that? Oh, okay. For this rectangle cut that we need to make, okay. So this particular edge of this, that is left edge of this rectangle, dashed rectangle, is at a distance of 8 mm from the central axis. Okay. In the same way, the right edge of this rectangle, okay, is also at a distance of 8 mm from this particular point in the front view. Okay, or from this particular edge. Okay, so therefore what I do now is I will go for making that rectangular cutout on the bottom face of the body. Means we need to make the cutout on this bottom face of the body here. Okay, so in order to do that, okay, I have already selected the bottom face, and I go for creating sketch on that bottom face now, and I'm going to keep this in bottom view. So click on this one. So this is the indication of 1 minute. This is top view. So this is bottom view. Select the bottom view. So once you select the bottom view, so I'm going to use the rectangle command here. Then I'm going to construct one rectangle. So I'm going to use corner rectangle here. Then I'm going to use corner rectangle, click it somewhere here and select the opposite diagonal corner like this. Once it is created now, means what I'm trying to create now is this dashed rectangle in the top view. Okay, is that clear? So now we have to define the dimensions of this dashed rectangle. So the left edge of the left side of this rectangle is at a distance of 8 mm from the central axis. So for defining that, I'm going to select smart dimension and this one. So the distance between these two should be 8 mm. So in the same way, the distance between this and this should also be 8 mm as it is given in the top view. So you can check it here. So the distance from here to here should also be 8 mm. This corresponds to this dashed line here. Okay, so then what I do is I go for defining. We need to define. What is the distance. We have to define the distance between this line to this line, or we need to define what is the distance from this edge to this line, top line of the rectangle, and what is the distance from this line to the bottom line of the rectangle. That is distance between these two. So as we can see here, somewhere here in the top view, they have given this line is at a distance of 8 mm from the top edge. Okay, and from the bottom edge, this dashed line is at a distance of 8 mm again. So therefore, I am going to define the distance between these two as again 8 mm here. Okay, and distance between these two will also be defined as 8 mm. Okay, so now you can see that the sketch is fully constrained. So once the sketch is fully constrained, what I do now is I am going to tilt the model like this slightly, and then I will come out of the sketch mode. Then I will go for features command tab. In features command tab, I am going to select extruded cut now. We need to cut the material within that rectangle, created rectangle. But what should be the height of cut? Height of cut should be 2 mm as per this front view here. So therefore, I am going to give the distance as 2 mm here. Then click on OK. So we have made one rectangular cutout on the bottom face of the body like this. Okay, is that clear? So once it is done, you may be thinking to create one more cutout like here. Actually that has to be done, but we are not. I am not going to do that one right now because later. First, I will complete all the features that we need to add on the right side of this on the right side of the body. That is, first I'm going to make one rectangular cutout on the right side portion of the body, which is as you can see in this front view. Then then I'm going to make this elliptical hole now here in the right portion. Okay, that is towards, means I am going to add all the features of the body which are present towards the right side of the central axis or the vertical axis. Okay, then once I complete all the features, once I include all the features of the body towards the right side of the vertical axis, then simply I am going to copy everything to the left side of the left side portion of the body by taking the mirror command. Okay, so therefore what I do now is, now I am going to make this hole here. So this hole is not as circular hole as it can be seen in the top view. It is the elliptical hole here. Okay, so therefore elliptical hole has to be made, and it should be made on this top face. So I will select this top face now, and then on that face I will go for making a sketch. Okay, and I am going to keep this in top view. Then somewhere here you will find, okay, in the sketch command tab, when you go to the sketch command tab, you will you will see different sketch commands. There you will find a command called as slot. So this one, okay, there will be an option called as slot. So select this slot option now. Okay, so then try to create the distance between the two semicircles, then try to move like this. Okay, so I have created a slot. You can see I selected the slot option, and I have created one slot which is looking like a elliptical hole now. Now we need to add the dimension of this slot. So how to add the dimensions of this slot? So dimension should be first read from the drawing sheet. So in this top view, they have given that this portion of the circle, semicircle, should have radius of how much? 5 mm. Or in other words, the distance between this horizontal line and this horizontal line should be 10 mm. So therefore what I do now is I will go define. So just close this one, then go to the smart dimension, go for defining this as 5 mm. once it is done, radius once radius is defined as 5 mm, then distance between the center should be defined as 8 mm. So distance between the two centers of the semi circles should be, that is, this horizontal distance should be defined as 8 mm. Okay, so I have defined that it is 8 mm. Then the center, this is the center of the elliptical wall in the front view. Okay, or this is the center of the elliptical wall in the top view. Now the distance of this center of the elliptical wall, okay, from the center of the body is not given, but instead of that they have given the distance between center of the two elliptical walls. So this is the left elliptical wall, this is the right elliptical wall. Okay, between the centers of these two left and right elliptical walls, the distance is actually 128 mm. So therefore, with respect to the central axis, okay, or the with respect to the vertical axis of the body now, okay, the distance should be how much now? It should be 128 by 2. So therefore, what I do now is I will select the center of this elliptical wall and this origin, and this distance will be given as 128 by 2. Okay, so now you can see that this entire slot entities are converted into black color, means the slot is completely constrained now. Okay, so you can tilt the model and you can verify here. Okay, you can verify here, you can verify that the slot is made on the top face of the base of the body. Okay, so this is the base of the body. On the top face of the base of the body, we have created this slot. So now what I do is I will come out of the sketch mode. I will go to the features command tab. There I am going to pick the extruded cut. So select the extruded cut, and I need to cut the material within this elliptical profile in the downward direction, and I need to cut it through all. Okay, so then click on OK. So now we can see that if I try to tilt this one, we can see here we have made an elliptical wall. Okay, so therefore an elliptical wall has been added to the body. Okay, on its right side, on the right side of on the right side of from its vertical axis. Okay, but same thing has to be done onto the left side, but we will do all that by using mirror option later. Okay, so I'm trying to add only the features which are present towards the right side of the body from its vertical axis. So this elliptical wall has been added now. So next what I do is I will go for making this wall. Okay, so there is a simple wall from here to here. Then this portion is uh, actually corresponds to square of 20 mm, means this is the uh, square wall. Okay, means this wall is not circular wall here, it is this wall here will have square shape, but here it will have circular shape. How it can be verified? So if you try to look at this top view, corresponding top view here, so this is given as what, diameter of 10 mm here, sorry, 10.5 mm. So therefore, since the top view is looking like circle here, so this particular portion of the wall from here to here should be circular, while for this particular length of 7 mm here, the wall should have square shape, and that square should have sides of 20 mm. So therefore, what I do now is, so first I am going to make one square cutout. So I will make this square cutout here. Okay, for depth of 7 mm. Okay, so and this 7 mm is uh, from this top face of the rectangular slot that we have already made. So therefore, what I do now is I will select the bottom face. Okay, of the body, not bottom face of the body. We have to select the top face of this rectangular slot that we have made. So this top face has to be selected here. Okay, so once it is selected, go for sketching on the selected face. So keep it in bottom view, and then what I do now is I am going to construct one okay, rectangle, and I'm going to give the dimensions of this rectangle as 20 and 20. So it should be 20 and 20. So once it is done, okay, so as it can be seen in the top view here, this particular square portion here, okay, is shown here with this dashed line. So this is the dashed line. Okay, so therefore I'm going to align. Okay, now I'm going to align this line and this edge here. So make them as collinear, and we need to specify what should be the distance from the center of the square to the which one, center of the square to the middle axis here. So but they have not given the distance from this axis to the center of the square here. Okay, instead of that they have given the distance between centers of the two squares. Okay, which are present on the left and right side of the middle axis. Okay, so that is given as how much here? 62. If it is 62, then from the middle axis, okay, so the distance of the square wall, okay, distance of the square wall should be how much? 62 by 2, that is 31 mm. So therefore what I do now is I'm going to uh, give the distance now. So let me add it here. So I can I will go for drawing one center line from here to here in order to get the center of that square. So then I will select this uh, I will select the midpoint of this line, and I will go for smart dimensioning between this and I think it is not coming. So let me define like this. So let me create one more center line from here to here. So two diagonal lines I have created with help of center lines. Then what I do is I'm going to uh, select the intersection of these two. I think it is not coming. Okay, intersection point is not taking, or I will create one more center line from here to here. Okay, so then I'm going to give the distance of this one as 62 by 2. Okay, I think it is not taking, so let me redo it. So instead of using corner rectangle, what I do is instead of using corner rectangle, I will go with center rectangle, so that will make my job easier. Okay, so like this. So then I will define. So instead of corner rectangle, use which one? Center rectangle. So here the distances sides of the rectangle should be 20 and 20. Add them. Okay, and then what I do, I will select smart dimension. The advantage of using center rectangle is we will be able to identify the center of the rectangle directly. Okay, so that will be easier for us to add the distance between middle axis to the center of the square. So this value is given as actually 62 by 2. So add it. So then I will select one of this top edge of the rectangle and this edge. So I will make them as collinear. Okay, once it is done, now you can see the sketch is fully defined now. Come out of the sketch mode. Okay, so you can see here where we have created the sketch. We have created this sketch not on the bottom face of the body. We have created this sketch on the top face of the rectangular cutout that we had done in the base of the body. Okay, so this here you need to be very careful. Then go to the extruded cut now. Okay, within that square we have to cut the material in the upward direction now. Now the question is for what height we have to cut the material. So this should be material should be cut now for a height of how much here? 7 mm. So therefore I am going to give this value as 7 here. Okay, so now you can verify we have made one square wall here. Okay, we have made a wall of a square shape. Okay, once it is done, we need to, so for the remaining length, means from here to here we need to make a circular wall now. Okay, and that circular wall should have a diameter of how much? So it should have diameter of 10.5 as it is given here. Okay, so therefore what I do, I will select this top face. Okay, so then on the top face I'm going to create a sketch now. Okay, then I will select circle command, and then I'm going to keep this model in top view. Okay, so then what I do is I'm going to take this alignment help, and I'll create one circle here, and this diameter should be 10.5, and I'm going to select the center of the circle that we have created and the origin by holding the control key, and make them bring these two selected points. Okay, bring these two selected points, that is center of the circle and the origin, on the same horizontal line. Okay, so they are aligned now. Then and also instead of bringing in addition to bringing on the same horizontal line, select those 2 points again. Okay, so also okay, I think horizontal is sufficient, but okay, so here now as it can be seen now, still the sketch is not turned to black color because there is a freedom for the circle to move to the left or right like this. So therefore we have to constrain this movement by defining the horizontal distance. So now we know that uh, uh, as it is given here, okay, so the distance between the center of this circle and this center of this circle here is 62. So therefore the half of the distance should be 62 by 2. Therefore I will select the center of the circle and this origin, and I'm going to define the distance between these 2 points as 62 by 2. So once it is done, you can see the sketch is fully constrained now. Okay, so once the sketch becomes fully constrained, go for cutting the material within that circle now. So use the extruded cut option, cut the material downward direction, okay, up to the next face. Okay, you can use up to next surface, okay, or up to next you can use, or you can use through all also. So if you give through all, so it will show you the preview, okay, like this, then click on OK. You can see now, okay, so we have made one circular wall, okay, and we have also made one square wall here, and we have made one rectangular cutout, and we have also made an elliptical wall here. So now if you try to get the top view, sorry, first let me keep it in isometric view. This is isometric view. If you try to see the top view, it is going to look like this, okay, and if you try to see the front view, it is going to look like this. If you turn on the hidden edges like this, it is going to appear like this. Now if you try to match the, okay, the hatched portion here, okay, or the sectioned portion of the body in the front view with the uh, front view that we are getting in the SolidWorks here, I think both are perfectly matching now. So you can see here both are perfectly matching, except that, okay, so there is a fillet here, there is a curved surface here with a radius of 6 mm, but that is not appearing in this front view here. So therefore let me uh, bring the model to the solid form, then let me change the orientation to isometric view. So means we need to add fillet here along this circular edge here, along this arc we have to add the fillet. So for adding that fillet, I will go for using which one, features command tab. In the features command tab, I am going to select the fillet command, and already that edge was selected, edge 1 was selected, that's why already we are getting the preview. And here this fillet radius should be how much now? So as it is given in this front view of the body, the fillet radius should be 6 mm. So give the fillet radius as 6 mm and give it OK. Now if you try to keep this in front view, and if you turn on the hidden edges, now you can see here fillet is appearing here, okay, this fillet is appearing, okay. So I think other than that we have, and one more thing, here it looks like there is a fillet. So here it the rectangular cutout that we have made on the bottom face of the body is having a fillet here, but they have not given the radius of that. But somewhere here in the part drawing sheet they have written that unless otherwise stated, uh, dimensions are in millimeter, chamfer should be made with 1 mm length and 45-degree angle, and fillet radius should be 1 mm. So therefore what we do is I'm going to add fillet here and here, okay. So that is what I'm going to do now. So let me bring it to solid form, keep it in isometric view, and I will turn the model so that I can see the bottom edges where I have to add the fillet. Select the fillet command now. So I need to add the fillet about this edge and this particular edge here, okay. So then give this value, unless otherwise mentioned it should be 1 mm, give it as 1 mm, okay. So now if you try to keep it in front view, and if you turn on the hidden edges, you can see it looks like there is a fillet here. So there is a fillet here. So now this is matching with the off sectional front view which is given here, okay. So let's try to check it quickly. So we have a small cylindrical wall here, okay, with V bottom. So it is appearing. We have a circular wall here, okay, from here to here, and then we have square wall here for inserting the square head of the bolt, okay. So then we have rectangular cutout here. So that rectangular cutout is appearing here, and we have one elliptical wall here. So that elliptical wall is also seen here. And let's try to compare the top views, okay. So now this is the top view, okay. So this top view, so you can see here this dashed rectangle here corresponds to this rectangle here, and somewhere here we need to have square rectangle with dashed lines. So that is also, that can also be seen here. And we have circular wall here, that circular wall can be seen here, and we have elliptical wall. We have this elliptical wall here. Okay, so same elliptical wall can be seen here. Okay, and we have two vertical edges here which corresponds to these two. So therefore we have added all the features of the body which are present towards the right side of its vertical axis in the front view. Okay, so therefore all the features have been added only towards the right side of the body from its vertical axis. So now the question is how to copy everything to the left side. Okay, so it can be easily done now. So what I'm going to do is uh, let me check where is my right plane. So this is my right plane, which will actually look like a vertical axis when I keep the model in the front view. So the right plane is going to look like vertical axis. So therefore what I do now is I'm going to copy everything from right side to the left side of the body. Okay, by using mirror option, and I'm going to mirror about this right plane. So how it can be done? Go to the features tab, go for selecting here, go for selecting mirror command here. So 3D mirror command should be used. Okay, so select the mirror command, and here it is asking which is the mirror plane. So mirror plane is right plane. I can select here. Okay, so here under the part tree or the design tree, select the right plane. That is going to be my mirror plane or the mirror face, and then it is asking features to mirror. Okay, so which features to be mirrored, that can also be selected in this part tree or the design tree. So I want to first select this cut extrude one. Okay, then cut extrude 3, then cut extrude 4. We are getting the preview here, and then cut extrude 5. Okay, and then fillet 1 and fillet 2. So all these things has to be mirrored with respect to the right plane. So select the 3D features to be mirrored. Okay, and then click on OK. So now you can see, so we have copied everything from right side of the body to the left side of the body. Okay, and if you try to keep it in top view, and if you turn on the hidden edges, this is how it looks. All the features have been copied from right to the left. Okay, and also if you try to keep it in front view, you can see it is going to look like this, which exactly matches this uh, front view of the body given in the part drawing sheet. So therefore this completes the modeling of part 1 of the plumber block, that is body of the plumber block. So now let me go for saving this file. Okay, press Ctrl S. I am going to save this file somewhere on the desktop. On the desktop I am going to create a new folder, and I am going to give the file name as folder name as okay, plumber block. Okay, so inside that I'm going to save this inside that plumber block folder, I'm going to save this as part 1 body. Okay, then save it. Once you save this file, you can go for closing this file. So don't close the entire SolidWorks software, just close this just close the working layout, that is the design layout. Okay, click here. So next we will see how we can go for modeling the part number 2 of the plumber block assembly, that is cap, and cap is given somewhere here. Okay, for the cap they have given the front view and top view. Okay, now we will see how it can be modeled.